All right, so let's just talk about a couple of applications right here. And I'm actually going to talk about this program on which I am recording this, uh, this particular discussion. This particular function right here, I've got f of x equals logarithm base 5 of x plus 2. And if I were to try to graph this function directly using the graphing tool from this particular program, I'm going to get a big fat nothing. And the reason why is that this program, it's called a smart board, smart something or other. Anyways, not that smart because it can't do it. So how do I actually figure this out? Well, it turns out that if I actually wanted to get a decent graph of this, and you might have noticed this in my last set of presentations, was that I would actually have to rewrite this in a different way. Now, again, I'll show you here, and I'm going to write up my I've got my little equations tool right here. I'm going to write this up in a way that the board I would think would understand it, right? So the first time I tried this, I wrote in y equals logarithm, and I have my little tool right here which I can put in 5, and I write in the quantity x plus 2, and I think to myself, all right, well, this should be something that this particular graphing program should handle. So what do? So I get this little thing, and of course when I highlight it, I'm able to grab my graph and post it in, and nothing happens. I think to myself, ugh, groan, what could I do? Well, the problem here is that the computer really has no idea what to do with this little 5 that's down here right here. In fact, it only knows how to deal with common logarithms or logarithms of the base e. So let me show you one way that I handle this. Um, what I did was, instead of writing it this way, I used my change of base theorem. And I said, well, let's say instead of saying logarithm base 5 of quantity x plus 2, I should use a fraction. So I'm going to take a common logarithm this time of the quantity x plus 2, and I'm going to divide it by the quantity logarithm of 5. That is now use my change of base theorem, and watch what happens. There it is. There's my graph. It's a graph that has a vertical asymptote at x equals -2, passes through the x-axis at x equals -1. See if I can actually get this thing to do something with it here. Plot some points. Here we go. Uh, Actually passes through the graph at -1, 0, would pass through the point 3, 1, would pass through a point like, let's see, 23, 2, right? These are all points on this graph. Now, it didn't matter that I used the common logarithm. I could have just as well used a graph with the natural logarithm. Now, just to show you, y equals, and I'll write it as a fraction again, the natural logarithm of the quantity x plus 2 divided by the natural logarithm of 5. And of course I have to be very careful when I'm graphing this because I want to make sure that everything matches. So this will show it in orange, but there it is. It's exactly the same graph as the one above. So the change of base theorem is actually kind of useful for me because when I'm graphing, and if you ever have a graphing utility calculator and you have to do this kind of thing, your graph would look at this guy right here and think to itself, but when we use the change of base theorem, we're actually able to rewrite these graphs in a way that, well, it's pretty useful for the computer anyways. Right? So there it is. Okay. Easy application, more to come.